Here we're going to look at example 2, where we identify even and odd functions from their equations. The question is the function odd, even, or neither? So we're going to look at part A, and we have f of x is equal to 4x to the fourth plus 5. The first thing we want to do with these is we're going to replace x with negative x. So we're going to take the function of negative x, and anywhere there's an x, we're going to replace it with negative x. All right, so that's all you need to worry about. You're just substituting a negative x everywhere there is an x. Now, we need to simplify this. All right, so what's going to happen here is that we'll have f of negative x is equal to 4. And what we're trying to determine is negative x to the fourth. How can we kind of rewrite that? So that's ultimately negative x 4 times, right? And these two, if you multiply a negative times a negative, you get a positive x squared. And these two, if we multiply these, we get a positive x squared. And then if we multiply these, we get x to the fourth. So what happened here is this would be x to the fourth. And all that's really going to happen in these cases is you're either going to have a positive or a negative coefficient. And you'll see that if your exponent is even, it's going to be positive. And if your exponent's odd, like it'll happen in part B where we have a 3 here, you'll see what happens with your coefficient. And then the plus 5 doesn't change because it's just a constant. There's no x variable. We didn't have to substitute anything. So now what I'm going to compare, because I can't simplify this anymore, I want to compare this statement to this statement. So my original to the simplified version of the function f of negative x. Now these two are the same. So my f of x, or my function of x, is the same as my function of negative x. And what that tells me is that this is an even function. Okay. Again, if f of x and f of negative x wind up being the same, and we're talking the same in terms of these two pieces, then it is an even function. And that's it. That answers the question for part A. In part B, let me just move this over a little bit. In part B, we're going to do the same thing. We want to replace x with negative x. So now we're going to look at g of negative x, and I'm going to plug in a negative x at each part of my equation. So these x's each became negative x. Same idea. We want to simplify. We want to get rid of that negative x and see what things will look like. So that 2 will drop down. The eraser keep popping up on me. And then we have negative x cubed, which is negative x times negative x times negative x. So here we would get x squared, bring down that negative x. And here when they multiply, we'd get negative x cubed. So here, this would be negative x cubed. I'll get to the next part in a second. So 2 times negative x cubed is negative 2x cubed. Let's change colors here. Now let's look at the 3 to the negative x, this piece here. So that 3 would come down. Negative x, actually let's save ourselves some time here. It's just negative x. We know negative x times 3 is negative 3x. So that would be brought down. G of negative x, we're now going to compare this piece here to this here. And one of the things I like to remind people of and look at is, did all the signs change? All right, so this definitely isn't exactly the same. This piece here is different than this piece here. All right, so it's not even. However, here I had a positive and a positive, and now I have a negative and a negative. All of my signs are different. The 2x cubed, this piece, was positive, it changed signs. This piece was positive, it changed signs. So since they changed signs, since everything is the opposite sign, this is an odd function. If only some of it changed, then it wouldn't be odd or even, it would just be neither. All right, so if you had, let's say you had like something like 4x to the third plus 2, this piece might turn to be the opposite, but if that 2 stayed the same, well, only part of it changed. So something like this would be neither, because it's not exactly the same, but it's also not the complete opposite. Okay, so be careful with that. What you want to do and what you want to remember is you're always going to replace x with negative x, and then you need to compare your simplified version towards the end with your original. And it can be either even if everything is exactly the same, it'll be odd if everything has had a sign change, and it'll be neither if some things have changed but not everything.